Hello, grade 11s. We are going to take a look at quadratic functions and how to graph them given a table of values. So, a table of values is simply a table where I have x and y coordinates, and then I plot those points on my graph. Now, the thing is, with x and y coordinates, we're not always given both coordinates at once, but how it works is we pick any value we want for x, and here are some provided to us. And then we plug in those values of x into our equation to solve for y. So that's exactly what we're going to do here. So we're going to jump into this first example. So I have y is equal to negative x squared. The big thing that we need to consider is that making sure that whatever we plug in for x, we plug in brackets so that we don't end up getting the wrong sign on our final answer. Whether we want it to be positive or negative, we'll find out. But if we don't plug things in brackets, we can get things mixed up a little bit. So here I have negative x squared, but instead of x, I'm going to plug in negative 3. And then I'm going to do that math. Now, I could plug this in exactly how it looks into my calculator. I do not have to actually calculate this by hand if I do not want to. But I do need to make sure that if I plug it into my calculator, I'm using the right amount of brackets, I'm using the right amount of negative signs, etc. And I should get negative 9. And I'm going to do this for all of these moving down. So negative in brackets for x, I have negative 2 squared. And when I plug that in, or when I calculate that by hand, whatever you prefer to do, I get negative 4. Can you pause the video and complete the rest of this table? Go. Okay, and hopefully you unpause and you completed the rest of the table and you get this. Now, what we've just done is we've come up with the y coordinate for all of those given x coordinates. So I can take all these points and plot them on the graph. So I'm going to start with negative 3, negative 9. Here I'm noticing my scale does not go up 1 square, meaning 1 on my x-axis. It says 3 squares is 1. So I'm actually going to go ahead and extend this scale here so that I can make sure I'm not going down or up by a wrong amount. I never assume that one box means 1. I always look for the markings to tell me. However, on my y scale, on my y-axis, it is 1 square is 1. So I'm going to go ahead not label those because I can count down by those ones pretty easily. All right, as I do this, I'm going to start plotting my points. So I have negative 3, negative 9. 1, 2, 3, 4, 5, 6, 8, 9 is all the way down here. So my first point is this guy. Now I have negative 2, negative 4, negative 1, negative 1, 0, 0. And now, something to kind of keep in mind, I know the remaining 3 points are this guy here, or these 3 over here. But also as we draw those, remember that things are symmetric, right? In a parabola, I have a symmetric curve. So if I were to take a look at this, plot all my points, and something looks a little bit off, I don't see that symmetry going on, then that's a good little red flag for me to notice and double check that I've plotted things accurately. Once I have those points plotted, I'm going to connect them with a smooth curve. Now, this might take a while for you to draw well, which means if you don't draw it well, have an eraser handy, okay? We are going to make sure we're connecting it with the smooth curve. I'm going to show you something that would be wrong first, and that's to connect everything with straight lines. Right, this is not something that we want. This is not something that it should look like. We should have that smooth curve in there. I also know that my parabola would continue on in both directions. I just didn't plot the point -4 as my x, or +4 with my x. But I do realize that it would keep on moving in that direction. So whenever I draw this, I'm also going to make sure that I draw arrows at the end. Now, when I like to do this, I like to do it in chunks. Oops. Because I find that sometimes I don't like what one of the chunks look like. It's easier to delete it. There. Things I also want to avoid. I want to avoid making that top very pointy. Sometimes I see people graph parabolas, and most of it looks good, nice smooth curve, but the top is super pointy. So we want to avoid that as well. And that's it. That's how we graph from a table of values. Now, this graph turned out really nicely for 2 reasons. Well, for one reason, really. And that one reason is that we have graphed the vertex. I know it's the vertex because when I take a look at a parabola is going to always be symmetric, okay? Which means if I take 2 points, like these two, that have the same y value, that means they've mirrored on top of each other to create that same point. So right smack in the middle of those 2 things is going to be the axis of symmetry, and my vertex is going to fall along that axis of symmetry. And that's true for all of these points in this case. Right? Those 2 points have the same y value, and they end up being equidistant away from the axis of symmetry. Same with these last 2 points. Equidistance away from the axis of symmetry. Now, in the next example, we're going to look at a graph that maybe isn't as nice to graph as this one was here. So let's take a look at the next one. The next one is y is equal to 2x squared minus 5x minus 6. And we've been given a table of values, again, where x has already been chosen for us. And we're going to plug in those x values into the equation to solve for my y coordinates. I'm always going to plug in my value of x in brackets so that I don't accidentally make mistakes with the sign. And like I said, we can plug that in exactly as seen into our calculators to get that number answer. We can also do this mentally, or we can do that in step by step. Whatever makes most sense to you, that's okay. If I was doing this mentally, -2 squared gives me +4, times 2 gives me 8. -5 times -2 will give me +10, minus 6. I end up with 12. Again, you do not have to show that work. You can plug it straight in, get the answer of 12, and all will also be okay. Can you pause the video and try completing the rest of the table, please? Okay, and now I'm just going to also do all of this. But at this point, I imagine that you've plugged everything on your own and you're just watching me go through this at a pretty quick pace. And if we plug all of those in, we do the math, we should get the following numbers. 1, -6, -9, -8, -3, +6. And just like before, I can take the x values and the y values we found, and I can plot my points. Okay. Taking a look at this, I'm checking out the scale again. I notice my scale is actually different from the one I had above. The scale on my y-axis is 1 box represents 1, which is good. But on my x-axis, I have 1 box representing... Sorry, 2 boxes representing 1. I'm just going to label them here. Just help my future self out. And what I'd like you to do is I'd like you to pause the video, try your best to plot things, and then come back. If there is a point that it cannot be plotted on the graph provided, move on to the next one. That is totally okay. Okay? Pause the video, go for it. All right, welcome back. So when I take a look at this, my first point, -2, 12, is actually too high for the graph. I mean, theoretically, it'd be up here, but doesn't fit on side. So I'm just going to move on to the next one. Next, I have -1, 1. Then I have 0, -6. I have 1, -9. I have 2, -8. I have 3, -3. And I have 4, +6. Okay. Now when I take a look at these, something that I kind of want to consider here is that I don't have that nice symmetry already provided to me. You know, I'm not looking at this and thinking, oh, wow, I can already see where that parabola is. Right now, I just have this collections of points. So let's talk about how I know some of the things. I know parabolas are symmetric, right? So no matter what happens, I know that a parabola will have that mirror effect, which is why I know this is not the vertex, right? Let's just talk about why this point is not the vertex right now. And I'm going to do that by connecting it to the next 2 points that are around it. If this point that I've highlighted in orange was the vertex, that means if I travel in any direction to the left or any direction to the right, I will have that same y value. It'll be that mirror image. But if I go 2 to the right, I'm here. If I go 2 to the left, I would expect to be there, and I am not, which is a bit of an issue. So I know that that orange point is not the vertex because I don't have symmetry. I don't have these 2 points or these 2 points, right? So I don't have symmetry there. That cannot be the vertex. Now, when I take a look at this, I know that this height is going to be hit when I get somewhere between these points. I don't know exactly where it's going to be hit, but I know that it would make sense to hit this height between something above it and something below it, right? So I'm just making up where that value might be right now, but just kind of looking at what could possibly exist. Which means if I wanted to mirror that, at least as best as I possibly could, I know that maybe I would need to have a point here so I can like make that reflection look the same. Which means my vertex has to be somewhere smack dab in between these, which looks like it's somewhere along here. Now this is probably the hardest thing that we're going to be doing, is to actually estimate something well. Now, do I know exactly how low it is or how high it is? No. But if I'm kind of imagining these curves that I've drawn in, it's not going to be way down here. That wouldn't make sense. And it's not going to be completely flat. I'm just going to follow the curve that's kind of created. So I'd go, and maybe I'd say that vertex is as low as this. I'm trying to match that general shape. This question of graphing from a table of values is probably the most difficult, but I use my knowledge of the axis of symmetry to help me get there. So we've predicted this axis of symmetry to look like it's going to be approximately here. And I can draw it if I want, if that's going to help me see those mirror images so that I can get that overall shape. So, speaking of overall shape, let's finish graphing this parabola. And I'm going to do it again on both sides. Make sure I get the best possible shape I can. If I graph things and I'm like, whoa, I really have to like swerve out of the way to hit those points, then I am going to go ahead and adjust that. Now, as I graph, right, I'm looking at that axis of symmetry the whole entire time. And when I see a point, I do want to acknowledge that there should be a point that's roughly across from it that would make sense if I folded this in half to hit both of them. Now, I know a lot of those orange points we didn't actually calculate the value of. We didn't have an x value of 3.5 or half or negative half or any of these. And they're all are just guesstimates. But whatever I'm drawing should be drawn with that, I don't know, that expectation, that knowledge that my parabolas will be symmetric. And if I take a look at any of those 2 points at the same height, I'm 1, 2, 3, 4, and a bit away from that axis of symmetry. Here I'm 1, 2, 3, 4, and a bit from that axis of symmetry. So even though my graph might be a little bit off, it seems very reasonable based on what I know parabolas to be, which are these symmetric curves. Okay, last but not least, we are going to take a look at one more example, which is this guy here. I want you to straight up start by pausing the video, plugging in the values of x that I've given you. Not only find the values of y, but then also to plot them accordingly. Go. Okay. And if you're back, you can watch as I do exactly what you just did. Oops. And I can get all of those y values by plugging that into my calculator. And I should get negative 49, negative 28, negative 13, negative 4, negative 1, negative 4, negative 13. Okay. And again, I am going to plot all of these values. I'm noticing on my scale that my scale for my y's changes by 1, but my scale for my x's changes by 1 for every 3 boxes. So I'm going to or label my scale a little bit better to kind of help me out. I'm also going to notice that I'm going into the negative land quite a bit. Actually, all of my y values are negative. And I'm just going to count, and maybe I'll label like every 5th one just with a number, just so it's easier for me to go and do. So negative 6, negative 7, negative 8, negative 9. This is negative 10. 1, 2, 3, 4. This is negative 15. Okay. You are welcome to label your scale as much, or your axes with a scale, as much or as little as you need, based on what makes the most sense to you. Okay? And I'm going to go ahead and plot these values. So I start off at -3, -49. That will not fit. -2, -28 will also not fit on my graph. But -1, -13 will. 0, -4 will. 1, -1 will. 2, -4 will. And 3, -13 will. And just like last time, we can look at this and go, okay, looking at this point, is it the vertex? Is it not? And I can confirm by knowing that my parabolas are symmetric. Here I have 2 points provided to me on the same y value with the same y coordinate, which means the axis of symmetry has to be right smack dab in the middle. 1, 2, 3 boxes, 1, 2, 3 boxes away from each point. And because that orange highlighted point does fall exactly on that axis of symmetry, it must be the vertex, which is super nice because it makes it a little bit easier to graph. So we're going to graph it. Smooth curve. To the best of our abilities, without trying to make the top pointy. And here, see, I notice I didn't pass through this nicely. I am not going to leave it and say it's close enough. I'm going to try again. Oops. You will get much better at this the more that you practice. So if you're like, wow, mine aren't that great. That's okay. It'll get there. I'm also noticing mine's a little bit pointy too. I might actually undo some of this and try it again. There you go. It's a little bit better. I'd accept that. But the idea is that when we're taking a look at a parabola, we are not always expected to be perfect on the first try. But trying a couple of times isn't something that takes a lot of effort. It's just we want to make sure we're giving appropriately and accurate drawings or depictions of those shapes so that we can get the best representation drawn down. Now, the last part of today's lesson is actually a review from yesterday's lesson. For this graph and this graph only, I want you to answer these questions. How many turning points do I have? What is the vertex? What is the equation for the axis of symmetry, etc.? I'd like you to pause this video and complete all of these here. And then unpause the video, and I will quickly do it with you. But pause, complete it, come back. Okay, welcome back. So when I take a look at a parabola, every single parabola will always have one turning point. My vertex is this guy here. The coordinates are 1, 1, -1. The equation for the axis of symmetry, that's always going to be x is equal to, and then the x coordinate of the vertex. Here I know I'm opening down. I can see that visually. I also know I have a negative leading coefficient. It's asking if I have a max or a min value. I'm going to have a maximum because I am opening down. And that max exists at y is equal to -1. My domain, how far left and how far right I go, because my parabola extends forever in both the left and right directions. I have the domain of -infinity to +infinity using round brackets. Or if you choose set notation, the set of all x such that x is an element of the set of real numbers. The range, well, I know I go from lowest or bottom value to the high as I possibly can go. I know the lowest I could possibly go is -infinity, and the highest I could possibly go is my maximum value, which is -1. And I use a square bracket for that -1. if I chose set notation, it's the set of all y such that y is less than or equal to that max value of -1, and y is an element of the set of real numbers. When I take a look at end behavior, every parabola that opens down unrestricted has the same end behavior. And that end behavior here is going to be Q3, quadrant 3 to quadrant 4. For y-intercepts, I do see that there's one intercept, and that occurs at 0, -4. For x-intercepts, I actually don't even cross the x-axis at all. I have no x-intercepts. None. So there's 0 x-intercepts. I have none. So I don't leave it blank because leaving it blank implies that you don't know how to do that question. So if there's ever a question like this where it says, hey, provide to me what the x-intercepts are, I'd rather you write something like, there are none here, there are no x-intercepts, none are available. You could say not applicable. You could write does not exist. All of those are totally cool, but I'd rather you write something down that I know that you know that there are none, as opposed to leaving it blank, because leaving something blank on an assessment on a test is usually because you don't know something. Okay? All right, and that's the whole entire lesson. There's some practice that follows. Please get her done. As you go through the practice, one of the great things that you can do is you could actually check your answers on Desmos. Now, as we go through this unit, I'd actually really, really love if you can check answers on Desmos. Why? Because I want you to get used to the Desmos app. I know we're not using it for the lessons quite yet, but the more you get used to it moving forward, the easier it'll be when we start having to use it for different lessons. So how I'm checking things using the Desmos app is I start by plugging in that equation. If you don't plug in y equals, it assumes you meant y equals with that parabola there. And then notice I'm plugging in separate equations that says x is equal to -1, -2, or -1, 0, 1, 2, and 3. And I get that from here. Those are the ones that I've plotted, so these are the ones I want to check if my values match. If I'm taking a look at Desmos, this graph here, and I tap on the actual parabola itself, I get all these little gray dots that show up. If I tap off the parabola, then those gray dots go away, but I could just tap specifically the parabola, not the line. Oy. And all those dots come back. And when I tap on those dots, it will give me the same coordinate points, or should give me the same coordinate points that I found in my table of values. Right. All right, that is it. That is all. Have a lovely day, and I will see you soon. Bye.